controlling powdery mildew or cucurbit crops through biological control agents. So cucurbits belong to the family of cucurbitaceae, which are the following. We have asgores, bittermelon, cucumbers, pumpkins, muskmelon, watermelon, just to name a few. Now, Liberty Hyde Bailey was an American horticulturalist who invented the word cucurbits for all the cultivated species of the family Cucurbitaceae. But this term is not used for all the species of the family. Now, in the New World, at the time, Cucurbita was the first plant to be decimated. The top three of Cucurbita are the Cucurbita maximum, the Cucurbita matuta, and the Cucurbita people. The species of the Cucurbita can be native from the Western Hemisphere, which are Mexico and Peru. And it also is recovered from Tamaulipas in the caves material dated all the way back to 7,000, 5,500 BC. So it's been around. It's been around for a long time. So the cucurbitaceae contains about 118 genera and 825 species. So that's really a lot. And distribute in the tropical and subtropical regions of the world. So what we occasionally eat is cucumbers, which is from usually from India, winter squash and summer squash, Peru, Mexico, the tropical Africa, we have melons, watermelons. So cucumbers have a high economic value. They are known for being a major source of food by having abundance of nutritional and medical properties for mankind. The food can be eaten immature or mature, baked, pickled, canned, or consumed fresh in a salad by mankind. Now you have medical properties also. So a squash can be treated for joint pain and get rid of parasites. So that's a fun fact. That's good to know.
That is good to know. I had no idea.
So cucumbers are also used for other uses than nutrition. You have the fruits for the bottle gourds are used for storage, drinking containers, nursing bottles, utensils, smoking tubes, musical instruments, decoration mats, floats for fish nets, and other items. The forage of the mature loaf of fruit, you can use that to exfoliate your skin or use for domestic cleaning and various other designs, including refrigeration. Now, in my research, I was more looking at cucumber and squash. Now, cucumbers have a huge wide range of pathogen diseases that affects the growth and the productivity. In my research, I was mostly looking at powdery mildew. Now, when you look at the chart, this is only, I'd say, 5% of the pathogen, 5% of the fungal disease. This is not all of them. But if you look at powdery mildew, CMV and SQMV, it has two diseases for the same fungus. So that's also something you could look at to make sure if you have this, you can make sure you treat it the correct way.
Wow.
Yeah. So according to USDA, the map shows that estimated of 400,000 acres have been harvested in cucumbers in the United States, but in Tennessee, it's around 4,000 acres, and this include all the farmers that come here at the farmers market also. So, like I said before, there are two powdery mildew that affected the cucurbits. Now, the symptoms. The symptoms of the powdery mildew appear as a white powdery residue on the upper leaf surface with circular patches or spots, as you can see. In severe cases, the fungus will cover both sides of the leaf and spread to the stem and the fruit. which remain small and do not develop fully. The leaves become brown and sugar, and defloration occurs, which decreases the photosynthesis rate. So we need a photosynthesis rate to produce enough fruit and make sure it has like a good amount to it. If the disease is not controlled in time, the symptoms can be severe and pretty much can wipe out your whole crop. So here's the environment conditions. So the powdered mildew spores, first, let's just say, is not something you can track to your plant like other disease, or a bug could come around or a dog could come around. Powdered mildew is pretty much airborne. So when I was doing my research, it was very hard for me to get that disease on the crop. So during the time, it carries by wind to the new host that infected the plants in moderate temperature. So around this time, 60 to 80 degrees is the perfect temperature for the disease to develop. And it happens in shady conditions. So for the spores and the fungal to grow are sensitive. They're very sensitive to extreme heat or direct sunlight. So you think it'll be the opposite. You think the sun will be like, oh, I'm getting the energy, I'm helping it grow, but it's the total opposite. The sun will actually burn the powdered mildew off your cucurbits because it can't take such extreme heat. So like in my research, I had I had like 36 or more cucurbits, but it was in a greenhouse. And one was not it was a different greenhouse, but it has coming through it. So the one that was in the closed greenhouse, it was very hard for me to get the powdered mildew on my crop so I could treat it to do my experiment. But when it was in the other greenhouse and it had air coming through, the powdered mildew was very high. So here are the most common in disease management. You have crop rotation, sanitation, biological control agent, which are BCAs, and conventional fungicide. Now for crop rotation, the techniques cause much more harm than good. They can be nutrient buildup that will take longer time to correct. Pests and disease from other crops can spread and infect more crops. And using the sanitation method, pruning and removing the parts of the plants that are affected and roughing remove the entire crops from the location can still promote disease to the other crops. So if you move an affected plant, you have to really look at the next plant that's surrounding it to make sure that that plant is not affected either. You could, like you said, you have like a soap water and you could spray it. That will help too. Water can wash some of that off, but it's not certain for it to go away. You could remove a plant, but it could be that 1.1% chance that is one powdered mildew spot on the next plant that you haven't seen before. And weeks go by and next thing you know, your whole crop is affected. So now we have the limitation of using conventional fungicide. We have the increased cost of the production, so it could be expensive, fungicide resistant. We have the toxicity of the environment because you are going to eat what you grow, and we have the destroy of the beneficial microbes that is there. So here are the advantage of using the biological than what I use for my research. So you have growth and productivity. That has been researched before. Use a biological control agent. It makes sure, let's say if you want to have a dogwood tree, and maybe your dogwood tree is not growing or it's not holding steady, you can put a biological control agent on it. It helps it grow faster. It makes sure if a storm comes that the trees are strong or the roots in the ground is more secure. Okay, so the advantage, like I said, the growth and productivity, it helps with stress. So environmental stress, like the weather. It makes sure if it breaks off, it gets moving to create new cells for the plant. As like we get a cut, and then the next thing you know, we have a scab and we have brand new skin. Or protection from pathogen and protection from insects and pests. Some bacteria with the bacteria biological control agent, most pets and most insects doesn't like the smell, or if it's get attached to it, it actually takes over the whole body of that insect or whatever pest is there. So most biological control agents in crop protection can be bacteria or it can be fungicide. So we have two. We have epitophytes, which is directly. So directly means right on top of the surface. So what's your name?
Julia. Yeah.
Julie. What Julia do for her cucurbits is she see any pest, she spray on their pest. That's directly. But in my research, I use endophytes, so I use indirectly. So pretty much whatever material I use, I try to put it in the system of the plant instead of spraying on top of the plant to see what the outcome can be. So my goal was to determine the effects to select the BCAs of powdery mildew in the cucurbit crops by evaluating the effects of 4 previously isolated BCAs in controlling powdery mildew, in evaluating the effects of the growth of the biomass, the effects of photosynthesis through the chlorophyll content, and the recovery crops through their disease rate. Now here, these are the BCAs that I use in my research: IMCH, PRT, PS, PSL. Here are their source, function, and references. And I like to show this because, as you can see, for the bacteria, these are all bacteria. And usually these bacteria come from a source. So they came from dogwoods and papaya. But with these crops, this is really harmful for these crops. So whatever fungal or bacteria hurts one crop can help and benefits another crop. What most people do not know. And then this is the references of all the people who have, did research in the past tense to find out this is true. So it either help the plants that is helping now, which is my cucurbits and squash. So with this, I use 2 seeds varieties, which is very easy. You can just go to any store to get the seeds. I use the Garden Street Perplus Hybrid Park seed for cucumbers, and an early summer crewneck organic seed for squash. So and the seed germinated, what I did, and you can do this at home. The seed was germinated in the lab for a week. So you can easily get a seed and some wet the paper towel and put it in the paper towel, and for a week it will start to sprout its roots. The following week, transplant it into the greenhouse. So I put it in my closet and I placed it in the greenhouse. The symptoms appeared within 1 or 2 weeks, so it came really fast. And I applied the BCA every week for 4 weeks. Now with the chart, I use a randomized complete block design of 4 reps of 4 treatments. So I made sure all the plants was in the same age. And the reason why I do that, because you don't want to have a baby plant and then an adult plant, and then you're trying to figure out the outcome, because most likely babies are most likely to get sicker than an adult plant. So you have to make sure everything was the same. So one thing that I wanted to look at with the powdery mildew, because like I said before, when the powdery mildew affects the plant, it decreases its photosynthesis, meaning it can have the ability to grow the production of food that it wants to need. So my hypothesis was different BCAs for certain chlorophyll content in cucurbits was increasing the photosynthesis rate. So it either try to get rid of it or increase the photosynthesis rate. My expected outcome was BCAs would either decrease or stop spreading the powdery mildew and preserve the chlorophyll content while increasing the photosynthesis rate. So what I did after I got finished spraying, I used this cool device to pretty much put it on a leaf and just check the chlorophyll rate. So here's the fun part. Okay, so this is the before and after treatment of the infected cucumber plants. In the first month, which is at the top, it shows that each BCA crop was affected by the powering mutant. In the second month, each BCAs either stop the spread or reduce the spreading of the disease. If you look at each BCA on the PS bloom, which means there will be fruit. So this is PS. So one of the questions people asked me when I was defending my thesis was, if I did it from 1 month to 2 months, why isn't it a bigger plant? Why does you don't see fruits? Well, because I never changed my pot. I still kept it in a small pot. So for me saying that, if you want a bigger production, you have to move the plant over to a different pot. But for here, I was just showing that yes, I do have powdery mildews on my plant, and yes, I'm using BCAs to treat it. And from here, you can tell that they have plenty of powdery mildew spots. But after a month, you can barely see any of them. It's more greenery, and it's not less green, and then also it produces flowers. So when you have flowers, most people don't know cucurbits have male flowers and female flowers. So when you have flowers, that means you know you're gonna have production of fruit coming very soon. So this is just a chart just to say that that the fresh rate and pretty much the first rate of the 2 months old BCA treated cucurbit plants, IMC8, PS, and PSL, show significant difference of fresh biomass compared to the H2O treated plants. And this is the chlorophyll. Well, this is for cucumbers, and this is for the biomass, but this is for the fresh mass. And I'm gonna tell you the process of that. So the fresh mass, like I said, the chlorophyll content, I use the machine. But with the fresh biomass, I literally had to wait for me getting done with the experiment, and I had to let it air dry. When I let it air dry, from using H2O, you have to have a positive and negative HCO and fungicide. I didn't use no BCA on there. So that's to say, I'm growing it like a regular person in the community. That biomass was less weight, but when I used the BCAs on it, it had more rate to it, it had more flowers to it, it had less powdery mildew, it either recover it or decrease it, and also I did have fruits. I had more fruits on the plants, and also it was a bigger weight than a normal size fruit. But this is only using all natural contents with it, which was the BCA. And this is pretty much the same results I ended up getting with the squash for the biomass using the BCAs. Another thing I want to show you is the image, how the powdery mildew look on the leaf. So this slide shows on an infected leaf, which you see all the white spots. It is not easy to see the cell cellulation, but you can see it in the picture B. Now all these pointy things, those are the powdery mildew on the leaves. So when you see so it compared to a non-infected leaf where you can see easily in cells in the picture B. And the normal cells are indicated by the white arrows per example. So right here, these are the normal cells, but these aren't. And using a microanalysis of an infected leaf, the leaf surface indicates the surface area analyzed with the microscope. So when you look at the white spot circuit in A, you can see the delimitation of the infected area that contains powdery mildew spores shown on the bright film C. Figure D and E are isolated spores things with the FDA to test the viability. So pretty much, we're just testing how much powdery mildew is on one surface of the leaf. And with, picture A, it's 90% of powder emitted. So, doing this research, this is chart going over the healthy leaves and the sick leaves using different BCAs. As you can see with the H2O, it has more sick leaves than healthy leaves without being treated whatsoever. Fungicide, it still has the same, close to the same amount, but using IUCA, PRT, PS, PSL, it had a higher sick leaf rate, a ratio of different plants that I had together than healthy leaves. Now with the healthy leaves recovery, that was the beginning part, but this is after the second month. It ended up the healthy leaves end up being higher than the sick leaf after the BCAs. Now, when we talk about plants, we really don't get into the inner part of the plant. We always look at the outer part and what we can do, but it's also important what you need to do for the plant for the inside. So this is this B13 glucanase, and it's abundant in plants. They play key roles in cell division, stress, and involved in flower formation. And that's the three things that we need for any plant that we need to grow. So as you can see in the chart, PSL was perfect for those categories to help your plant grow. It has the highest B13 glucanase other than comparing to H2O. Now, peroxidase reaction induces distress. So we have planned out also, like even with us, if we're very stressed out, we probably need to take a break, take a nap, drink some coffee, whatever the case may be. But when using the BCAs, we're trying to figure out how we need to lower that. So PRT treated plants are significant difference of having it other than PSL in the other chart. So the least amount of peroxidases are PS, PSL, and IUCA. So that's the most likely BCAs that I would use for my crops. Now with this, within the plants, it helps in a stress stage. They produce high level of enzyme, which is making the crop brown. So when you have your banana sitting out, this is what you're actually looking at. So for us to try to decrease that, INCA and PRT will treat a significant difference in reducing the stress in your crop. So just a little conclusion, IMCA, PS, PSL treated plants display a higher fresh biomass compared to the H2O treated plants. There's really no differences in the chlorophyll content. The PS, PSL treated plants display higher rates of recovery and or healthy leaves after the treatment. PSL treated plants display a higher B13 glucanase compared to H2O treated plants. Fungicide and PRT treated plants display lower peroxidase compared to the H2O treated plants. IS8 PRT treated plants display lower polyphenol oxidants compared to the H2O treated plants. And these are my announcements. So thank you so much.